pleasant evening to everyone. Hello to all our viewers from Facebook and YouTube. So, welcome to StackLeague Tech Session Solidity Blockchain Development. So, I am King and I will be your host for this evening. So, before anything else, I would like to remind everyone that if you have any questions regarding our session for tonight, please type them in the comment section and we will be addressing them later at the Q&A session. Also, to help the Stack League team improve the session for you, answer the following question form after the live session. So here's the link. It's bit.ly/Stack League session feedback, or you can scan the QR code flashed on your screen. So I'll be flashing this one for about 5 seconds, so you can scan the QR code. All right, so moving forward, before we dive in into tonight's session, we would like to give you an overview of Stack League, especially if it's your first time to join a Stack League event. So Stack League is the Philippines' largest online programming league, and its mission is to develop programming leaders to inspire the nation into coding. So now, in its second competitive year, Stack League wouldn't be possible without the support of our partners. So we're very fortunate to be supported by the top companies in the industry. So we have our platinum sponsor, the Pocket Works, silver sponsor, its Coding Chiefs, and bronze sponsors are Microsoft, Deltec Systems, Upper.ph, Recruit Day, Gcash, and Likha IT. Also, our media partners, we have Spark Up, Apps Gadget, Was Up Pilipinas, Corner Magazine PH, Android Desk, Megabyte, Backend News, Blue Wing, and Manila Republic. And of course, the same goes for our community partners who help the league reach as many programmers in the country as possible. Okay, for our Stack League ambassador for the month of July, we would like to congratulate Mark Genesee Mamore for being the Stack League ambassador for July. So winning the 3,000 pesos cash prize and a Stack League t-shirt. So if you want to be the next Stack League ambassador and win the cash prize and t-shirt, the program is now open for the month of August. So you can find the full mechanics at our website. It's bit.ly/StackLeagueAmbassador 2022. And now to know more about the Stack League overview, here is Haifa Karina from Stack League. Take it away, Haifa.
And I will be giving you an overview of what StackLeague is all about. StackLeague is the Philippines' largest online programming league. The mission is to develop programming leaders that inspire a nation into coding. The tournament is powered by StackTrick's fully automated talent, analytics, and assessment platforms. Now, what are the highlights of the league? The Pioneering Programming League was launched last March 16, 2021, and is now gathering over 15,000 tech talents across the country to test their leadership, perseverance, and coding skills with a promise of nationwide media recognition, lots of prizes, thousands of tech job opportunities, and access to invitation only events. The league's year round cash prize pool is now at 10 million pesos in the duration of the whole competition. That is for 2022. And one of the highlights in the Stack League is the weekly Stack Race, which is both for individual and teams. Each week, the top 10 challengers and the top 3 teams are announced all across Stack League social media platform to recognize the challengers who stayed on top of their rankings. Apart from this, we also have the Stack League featured programmer and team campaign. The weekly top 10 challengers and top 3 teams are going to be featured on Stack League's website and on our social media channels. Now, Stack League will also be hosting numerous tech and career sessions all throughout the year. Aside from this, there are also exclusive trainings available for ranking to the next challenger levels. And these events and trainings are all for free. So if you are interested in different industry trends, technologies, best practices, as a challenger in Stack League, you will have access to all of these learning sessions. Now, what's next? We also have the Stack League Ambassador Program, and it is a year-round initiative to reward Stack League challengers who go beyond the competition and inspire the nation into coding. To tell you more about the StackLeague ambassador, here is a short clip for you to watch. All right, and that's for the Stack League Ambassador, wherein you will get, if you become the Ambassador of the Month, you will be receiving 3,000 pesos. And if you become the Ambassador of the Year, you will be receiving 20,000 pesos. And there are multiple ways for you to become a Stack League Ambassador. One is to really refer as many developers or interested developers to take on the challenges at StackLeague. That's one. And then the other one is to post blogs or features using your own websites or other blogging platforms. That way you also get ambassador points. And now for the supported programming languages in the league, we have JavaScript, Java, Python, C Sharp, and PHP. Now how the ranking system goes. So after signing up, you will start at the bottom with 0 points. All you need to do is solve as many challenges as you can and earn the corresponding points. So the more points you earn, the higher your ranking goes. Once you have accumulated enough points, you can now get to the next level. You've got the next level where most opportunities are unlocked for you. So there are 3 challenger levels. We have bronze, silver, and gold levels. Now, the new thing that this year, 2022, is that the challenger level up now has prizes. So if you will able to unlock bronze level, you will be receiving, oh, here you go. You will be receiving 100 pesos. So that's 100 pesos as soon as you level up to bronze. Then as you level up to silver, you will be receiving another 100 pesos. And when you reach gold, you will be receiving and rewarded with 300 pesos. So overall, you will be receiving a total of 500 pesos as you level up from unranked, bronze, silver, and then gold. Okay? So now if you become part of be one of the 10 challengers to win this week. So on a weekly basis, we have rewards for the top 10. So there is also the StackLeague Treasure Chest. That is what we call the initiative, wherein the weekly top 10 challengers will receive 500 pesos cash prize. What else? So there are a lot of things happening in StackLeague, but this is also one of the highlights of StackLeague for the year. We have what we call the StackLeague Playoffs. So what is a playoffs? It is a single elimination tournament featuring all monthly qualifiers where all weekly top 10 StackLeague challengers will automatically be invited to the monthly qualifier rounds, and you can read the mechanics at StackLeague Playoffs 2022 to know 2022. And to know more, here is another clip for you to watch. Okay. All right. So as you can see here, we have the monthly qualifiers happening every month. And that happens, the playoffs monthly qualifiers happens every fourth Saturday of the month. So that's every from 10 a.m. to 3 p.m. So every month we are giving away for the top one. The top one winner will be receiving 5,000 pesos, and the top two will be receiving 3,000 pesos. Now, if you are interested in the schedule for the upcoming months, these are the schedules that we have. You can see them on your screen. Now, all of these players at the end of the year, by December, there will be a single elimination, as you can see the chart here, and the best players in the league will be crowned here through the playoffs. Now, for our new players here, if you cannot make it in the top 10 and you are still trying out, then that's the Stack League Lightning Series is the event especially made for you. So every level you have your own rank. So we have unranked, bronze, and silver challengers, and we do this one on the monthly basis as well. So for the unranked category, if you are still new here, we have an opportunity for you. It happens every second Tuesday of the month at 6 p.m. So that's where all unranked categories could experience a 1 hour programming competition and also get prizes. On the third Tuesday, we have the bronze category. So many of the unranked challengers get to level up and then they can now join the bronze level category. So the prizes here would be the top two will be receiving 1,200 pesos plus a limited edition Stack League shirt. Now, for the fourth Tuesday of the month is when we do the silver category. So as you try to level up, there are more chances for you and there are bigger prizes waiting for you. So for the silver category, the prizes here would be 1,500 pesos plus Stack League shirt plus Microsoft jackets. And with that one, I give you the overview of Stack League. Now, let's go back and welcome back our host.
All right. So thank you so much, Haifa, for giving us an overview of Stack League. Okay, so let's not delay this any further. Let me introduce to you our speaker for tonight. So our resource speaker is a blockchain development lead at UBX Philippines with a proven experience in the banking industry. He has a degree of business economics from University of the Philippines, and his field of expertise includes blockchain technology, operational excellence, Lean Six Sigma, JavaScript, and Python. Let's all give a warm welcome to Marco Lorenzo Romero. Good evening, Mark.
Hi guys, good evening. Okay, so that's my cue. Okay guys, so for now, I'm gonna be teaching you Solidity. So bit of some disclaimers. This will be basic Solidity. The assumption here is that you are knowledgeable programmers, familiar with some JavaScript. Actually, JavaScript would be really helpful. Um, and I will be teaching you the basics, so don't expect anything too deep. And we will start by looking at how to create our own ERC20 smart contract. And let me share my screen. Okay. Okay, wait a while. My browser is having issues. Um, okay. I'll rejoin just to fix my issues. Thank you.
Okay, so while waiting for our speaker to reconnect from some technical issues and difficulties, I would like again to remind everyone that if you have any questions later on for our Q&A for our session, you may type them in at the Q&A session. You may type them in at the comment section, and we will be addressing them later at the Q&A session. So for now, let me just get please stand by. We are experiencing, or the host is experiencing some technical difficulties with his presentation. So again, if you have any questions, please feel free to comment them in the in the comment section, and we will be addressing them later at the Q&A session.
Okay. Hi guys, I'm back. Sorry for that. Sometimes Chrome just bugs out and blocks me from sharing my screen. Okay, so as I was saying, I'll be teaching Solidity. So right now we'll be using an online IDE for this. It's a very useful tool. So even though it's an online IDE, it's a very good tool for experimentation and prototyping. Your Solidity smart contract. So if you don't know about it yet, just search about Remix Ethereum and you'll get access to their IDE. Just click Remix IDE. This will be where I'll teach you how to work on smart contracts. So we will be creating an ERC20 smart contract, and to know about the details of what ERC20 is, you can search EIP20 on GitHub just to see the original spec sheet of what creates an ERC20 token. So this is the original proposal, the final and original proposal. This specifies the functions that you need to enable and what the idea of that function is. Right? For here, you have functions that are required to be implemented, but you also have optional functions, like for example, name, symbol, and decimals. Although a lot of ERC20 tokens still implement the optional ones just for ease of use and to be able to differentiate themselves from other tokens, because it's easy to find out what token you're dealing with when you're looking at the name. Although, of course, we don't just stop at the name, we need to make sure that you're dealing with this right address. So aside from this, you can also look at the interface from OpenZeppelin, which is one of the leading Solidity library. And let's go to GitHub. They have their own implementations, but for the sake of, for other projects, you might be able to just get the implementation directly from there and differ some implementations. But for the sake of learning, we'll go through all this without importing anything from OpenZeppelin. This is more of a once you know Remix or Solidity, you can go straight here, look at how they're doing things, import some contracts. But for the sake of this session, we won't be going through OpenZeppelin. This is more of just so that you know. All right. So let's start. For Remix, you can create your own contract. So you can have multiple workspaces. I'm just going to use the default for now, but workspaces are a good way to segregate your project so that you don't mix up your files across different projects. Let's create a new contract. Let's name it token.sol. Okay. So first thing, you can specify what license you use for Solidity. Most common is MIT. Although this is not required, it's just nice to have, but let's just go through it either way. Don't actually have this memorized. This is something that I just have on the second screen. We're using MIT. The first actual line of code you do is you declare what version of the compiler you're using. So to do that, you use pragma solidity and the version. For versions, you can use the caret. So 0.8.14. This means that you're going to be using the latest version available. So you can use up to the latest version of 0.8, right? You can do 0.0 greater than, or yeah. You can have other versions here. You can't remember the syntax, but ideally, the best way is to just make it static, because jumping between different compiler versions might introduce bugs that you might not be aware of. So just make it static, or add the caret to take advantage of the bug fixes for when you're compiling. But for a lot of projects I just make it static. So now I'm using, actually the latest one is I think 15. So 0.8.15, right? Next is to start with the contract. To do that, we start with contract, and we name that contract. Naming convention for contract is upper camel case. So let's name this something simple. Let's name this token. Okay. So let's get back to the EIP, the ERC20 standard. So it says here we need to implement 3 functions. That's optional, but we will implement them. We'll implement name, symbol, and decimals. So name just returns the name of the token you're using. So to do that, let's create a variable, a string variable for the name. When you're declaring a variable, you need to also declare the visibility. For variables, you have 3 visibilities. You have public, internal, and private. Public means it's available. It's gonna create a getter function so that contracts or to interact with your contract, you can just interact with that variable, and you'll get that variable. Private and internal makes it that it won't be accessible through it won't create a public getter function, but it doesn't mean that your variable is completely private, because in the blockchain nothing is private. It just means that other contracts won't be able to access that data readily, but a person who is persistent enough can just go into the blockchain and read the data directly. So for this, let's say that I'm making an internal variable named for name, and let's say that my token will be, I'm just going to make it name, and another internal one named one symbol, right? Lastly, so name and symbol should return a string, and decimals should return a uint8. So this time, just to show the difference between internal and public, I'm going to create this as public. Let's name it decimals directly. Okay. So we have the variables, but we didn't really assign what the values of those variables will be, right? Maybe let's assign decimals. Let's assign 18 to decimals. For ERC20, traditionally it's normally 18, but other contracts have it differently. Contracts like USDC, I think, have it at 6. That's USDC and USDT. But mostly they have the decimals at 18. right? So now I can actually compile this contract. To compile the contract, make sure that your compiler is the right version because I'm using 8.15. I need to use 8.15. If I use 8.14, it's going to error out. See? To compile your contract, you can press Command S for Mac users here, probably Control S for Windows users. So 8.15, if I use this and press Command S, it's going to compile. Okay, check mark, right? And I can deploy this. So if you see at the left side, we have several icons here. The S icon for Solidity is where we choose the compiler and add several other options. Here, the Ethereum icon with arrow is where we interact with an EVM. So it could be something connected through our injected provider, which in this case could be MetaMask, something local, if we're running a node locally, either testnet or mainnet, or we can just use their Remix VM, which is, I think, a Java-based implementation of the EVM. It's going to give you several accounts. And here, just choose what contract you have and click deploy. Once you do that, you're going to have the deployed contracts here, the bottom left. You can expand the list. And if you see here, we have several variables. We have name, symbol, and decimals. But only decimals has a function. So this is the function that I was talking about. This is the getter function. And when I click this, it's going to run that function. It's going to return the value that is stored at decimals. And in this case, it's 18. This is because it's a public function, and the public function will automatically create the getter function for you. So technically, we're already fulfilling the requirement for decimals, but we're still not fulfilling the requirement for name and symbol. Okay, so those are the variables. We have other variable types. We have bool. We have, for numbers, we have uint and int. Then you specify how many bytes you need. Uint 8 being one of the smallest. Well, actually the smallest. Then you have uint 256 as the largest. You also have structs and other variables. Hopefully, you've read through the pre-read materials in Solidity Read the Docs, because I might not be able to go through everything. If you have questions, feel free to ask, and I will, if relevant, I will answer them as I go. Next, to fulfill the requirement of giving the name and symbol, we'll need to create a function. So let's just copy paste this, right? Okay, so to create a function, we say function, similar to JavaScript, right? We name the function, parentheses for the parameters. In this case, we don't need any parameters. We need to specify the visibility of the function. For functions, we have 4 visibilities. The visibilities being public and external. I'm just going to group similar ones. And you have internal and private. Okay, so some differences. Public and external, they are available publicly. Difference is that external has some gas benefits. I won't really discuss how and why, but that's something to know. Internal and private means it's only accessible through the contract. So it could be good for helper functions, but just make sure that sensitive functions that you don't want the public access to would be marked internal or private. Difference between internal and private is that internal will make it accessible through its inheritance, and I think private is only accessible. Private is stricter and accessible only to that contract, I think. Yeah. Okay, so for this case, because we want the name to be publicly accessible, we make it public, and to follow the spec, it is going to be public. View means that it's kind of like you're telling the compiler that this function will not edit anything in my smart contract. It won't edit state. It's just there to retrieve values but not edit anything. You also have something stricter, which is pure, which says this will not even read any values on your contract. This will just be a computation. This is normally used for mathematical functions wherein you're not really reading anything. It's like just x times 5, right? So for our case, this is going to be view. And returns means you are planning to return this type of variable. And in this case, we're returning the name, and this is a string, right? So simple, we just return the name. Okay. Oops. Also in Solidity, you need to finish your lines with a semicolon. It's very sensitive when it comes to that. And also, strings, and sometimes when also bytes, not bytes 32, just bytes, you have to identify if they will be in storage and or memory. Difference here is that memory is more on volatile. You're not really changing anything. And in this case, we're not changing anything. If you instantiate something on storage, when you change the variable, it's going to be saved. So in this case, we want to do it memory. Okay, if I deploy this, we will have two functions, right? We have decimals because it's public, and now name because we have a function for it. But for name, it's not gonna have anything because we didn't really put in a value for it. So one thing, similar to how the init function in a class, right? You have a constructor, and you can specify how to initialize a smart contract. So this function is run when you deploy that smart contract. It can take some parameters. In this case, let's take the parameter string. This you also need to say that storage or memory. Not really saving anything. We're not saving this specific variable, so we're using memory. All right, let's call it name, and it's gonna be correct. Oops, sorry. And we're gonna assign the internal variable name with the new name. Okay. So now, when we deploy this, your deploy and remix will ask for a. Okay, let's comment this out first. So earlier, it was just a button deploy, right? But because we added the constructor, it's gonna add in asking for a variable string, which is for the name. Let's put the name, which is StackLeague, right? So let's say stack, say stack, and read all caps just because transact, right? Now, because of that, during your oh okay. So let's say it's shadowing an existing function name, right? Let's just use new name. Let's redeploy. So okay. And because we assigned the new name to our internal variable, when we click name, it's supposed to return stack. Right? So that is how you initialize the smart contract when you deploy it. So if you want to run a function prior to that, you want to maybe mint some tokens or something, you do it through the constructor. Another way of doing is to add an initialize function, but that's more for advanced use cases, maybe even proxies. Right? So we go to function. The other thing that we need to implement is symbol. So function symbol public, right? It's going to be view because it's not going to edit anything. We just need to get the value, and it's going to return a string because symbol is a string. memory. And it just needs to return symbol. And as earlier, if we do this and we deploy, symbol doesn't have anything. So let's add int or constructor. Let's add string memory symbol. Now let's assign, make this new symbol. Add in symbol, right? And assign the new symbol to that. Now, because we're doing that, when we deploy, our contract will have stack. Let's say, SDK. Sure. Transact again. And we have 3 functions. So when we call them all, it's returning the right value. So we have the stack token with the symbol STK and 18 decimals. So we've implemented our optional functions. Cool. Okay, so now let's implement the required functions. So we have a couple, I think we have 6. Let's start with total supply. So for for ERC20 tokens, total supply needs to return how much supply your token has. So it's a getter function. It's public. View returns, and total supply is int 256 variable. So for int 256, you can shorten that to int, just uint, or uint 256 if you want to be explicit. You don't need to specify if it's memory or storage because it's not required for these types of variables. Specifying is only required for the longer types like string, bytes, I think struct. Yeah, struct. But for this is fine. Okay, so we don't have a variable for total supply yet, so let's make that variable uint256 total supply. So before making this, you can make it public so that you don't even need to create total supply function anymore. That's totally fine. You can make it internal so that you're more explicit that you have that function. In this case, let's make it like that. Some reasons why to make it like this is because if you want to have some kinks in your implementation. For example, if your total supply shouldn't just reflect your internal value because you might have functionality that gives interest rate. So your total supply might be multiplied by interest rate times time elapsed. So that's why you'd probably want to do this. You might have interest rate times time elapsed, something like this, instead of just doing it normally. But for our case, either doing this public or doing it through a function is going to be fine. Depends on what you want or the coding convention of where you are. Again, for internals, it's also good to add an underscore so that you can specify that your function or your variable is only used internally. This case, we have that, but again, if we deploy this, it's going to be 0 because we don't have a total supply yet. One way to make total supply is upon deployment, the account that deployed the smart contract or the ERC20 token will get all the supply. So what we can do is message that sender. So this is how we can specify that your message that spender will identify how much. Sorry. Let me repeat. Message that sender is the address that sent that transaction. So this is who we want to assign that to, right? But before we assign it to that person, we need to fulfill another function, which is balance of. So to assign balance, let's just make total supply fixed first. Total supply is, let's say it's 1 billion. You can type it like this, so it's more explicitly, it's easier to read. So you know this is 1 billion, right? Times 1E18. Okay, so we're doing it like this because you want 1 billion tokens, but your decimals is 18. So we need to multiply it by 1 raised to 18. So that's 1E18, scientific notation, or you can just like that, something like that. No, not like that. Times 10 raised to 8. But for the sake of brevity, it's just 1E18. Okay, so 1 billion times 1E18. Because if we just type 1 billion and you have 18 decimals, it's gonna be a very, very low number. Another thing in Solidity, we don't have floating point math. It's all whole numbers. So there, that's why we have 18 decimals, because if you want to do math, we're gonna do it through all that, and it's divisible up to 18 decimals. So that's why we're saying that ETH and several smart contracts are divisible up to 18 decimals, right? Okay, so now this is our total supply. Another way of doing this is you can just assign total supply here. Instead of doing it through here, you can even take it as a parameter through your constructor. So it depends on what you want to do. If it's a fixed value, you could probably just do it directly through the smart. Actually, let's do it through the constructor. So now you're assigning that, but that balance isn't going anywhere. We have total supply, but nobody owns that balance. So how do we assign balance, right? So balance is, we can assign balance through mapping. So mapping is we assign specific variable to another variable. In this case, we're assigning to an address because that address will own. We're assigning a UN256 to an address because when we get that address, it's going to return the balance. So internal balances like this. Now, if you want to give your a balance on address, you just use balances. So we call that mapping. And this is the mapping, right? Square brackets, the address you want. So in this case, this is going to be the message sender. Message sender is a built-in variable, not variable. It's a term. It's built in here. Message is built in and it has several properties. Sender, can't remember the other ones. Value, gas, I think. But important here is sender, so that whoever sent the deploy transaction will be the message sender. And in this case, you're the owner, you're the message sender, and let's assign the total supply to you. Return total supply. Okay. So now when you deploy this, you still need to assign stack and stack, right? And when we do decimals, name, symbol, total supply is a big number because this is going to be parsed still. This is 1 billion raised to the to 10, 1 billion times 10 raised to the 18. Okay. But if you've noticed, we don't have balances. That's because our mapping is internal. We can make it public again, but for the sake of this, let's have it accessible through a function, which in this case is the function balance of, coming from the ERC20 contract, right? So let's just copy paste this. So let's go through this. So for balance of, you want to pass an address because you want to identify what address you're trying to see the balance of, right? It's still public because you want it accessible publicly. and it's still view because you're not editing anything, you're just looking at the balances, and it returns a UN256, which is the balance. Okay, to do this, we just return, right? We need to access balances, and to do that, we type balances in square brackets. The address that we want to check out in this case now is the owner. That right there. That's it. We now have a function to access the balance. And if you check this out, if we deploy this, we have a balance of, and it takes in a parameter which is owner. So the owner here for Remix, you are given several accounts. You have how many is this? 15? Not sure. You're given several accounts, and the one I've used is the first one. I can copy that, put that here, and I'm expecting that all my total supply is in this account, and it is, right? But if I go to my next account, which I didn't use to deploy, I can copy this, go here. It's going to be 0 because it doesn't have any balance. So now we have we've done total supply and balance of, right? Now we have to do transfer. Okay, so for transfer, you can see here that it needs to transfer the value to the address 2, and it needs to fire the transfer event. Okay, so let's say what an event is first. So in the spec also, they specify the events that you need to put in. So they put in transfer and approval. Let's copy this. An event in Solidity is something that is emitted. Well, it's something you can emit, and outside nodes can listen to it. So inside Ethereum, events aren't really useful for smart contracts because smart contracts can't access events. They don't have that capability. But other programs, like if you have a bot that's listening to the transactions of whales, they can listen, they can subscribe to an event. You can specify that, okay, I want to listen to the transfer event of USDC because I want to know where and when and where a specific USDC is transferred, right? For events, you can specify what you want the event to emit. In this case, it's emitting the address from where it came from, where it's going, and how much was transferred. You can also see here that it has indexed. Index means that this variable is filterable. So if I listen to transfer of the stack token, I can filter na I want to listen to the transfers of this particular account because this particular account is a big whale, and whenever he sells, everybody else follows. So I want to know what he does specifically. I don't care about anybody else, right? Because initially, if you don't filter, you'll get every transfer, and that might be too big of a data if you don't really know what to do with it. But if you want someone specific, you can filter events based on the index parameters, right? You can also filter here to where it's going in case you want to say, okay, I want to listen to this whale because whenever he accumulates, markets move. So that's one way to do it, right? So the other event, so that we have this event approval. So naming convention for events is you put in event, upper camel case, and you specify the parameters you want, and you identify the ones you want indexed. For index, you can identify up to 3. Not sure if that changed yet, but before it's been 3. So yeah. Okay. So now let's go back to transfer. So before I go there, so we have events, but if you've noticed, for everything else we've done, we're not really doing anything yet. That's because they're all just view functions and they don't edit anything. But there is one instance we can fire the event, because if you see here at the start of our what's that called, of our at deployment for our constructor, we assign 1 billion tokens to the message sender. So we can emit the event here. To emit an event, it's basically you type emit, the event you want to emit, and the values that you're going to use. So traditionally, for minting transactions when it comes to smart contracts, your from should be address 0. This is basically OX 00000 blah blah blah, right? This is to signify that this token is coming from nowhere and it's basically getting minted to that address. And that address is message.sender. And the amount was total supply. Right? So now when we do this, an event will be emitted and people who are listening can see this event. Well, technically they won't be able to listen yet because this contract doesn't exist. But the good thing about smart contract events or Ethereum events is that you can listen back from the very first event ever emitted, because you can specify from what block you want to start listening to. It's not like some pub sub relationships wherein if your subscription missed previous events, you won't be able to listen to it anymore, right? For Ethereum, you can technically query every event since the past. Okay. Oops, what's happening here now? Okay, semicolon. Always remember the semicolon. So now we have these, and let's start with the functions that do edit state. Let's start with transfer. Okay, so for transfer, we need address to, so where the token is going to and how much of the token is being transferred. It's public, but if you notice, this time it's not view because we are editing state. We're not just getting a value, we want to edit something and returns a bool success. And this is something that other contracts can use to use as a require so that they can be sure that the contract was successful or the transaction was successful before implementing something. Traditionally, if you've looked at blockchain and Solidity before, there were ways to compute on-chain. It's called safe math. We don't need it anymore starting 0.8. If you're using anything lower than 0.8, you still need to use it. But at least for our purposes, it's not needed. But a good way to start with your functions is to require. So we have this, what we call checks, effects, interactions. So what you first want to do with a smart contract function that edits values is you check. You check your parameters and everything required. You check if all your parameters are present. You check if the values are correct, right? And once that's done, you do the effects. So inside your smart contracts, that might affect things like it might affect total supply, it might affect balance, it might affect names. You want to edit that first, then you do interactions. Interactions means things that are functions that will be called by your smart contract from other smart contracts. So in case your smart contract needs to call another smart contract, you want to do that last, because we have what we call entrancy bugs, well, exploits, and it's basically one of the safer ways to do things. Checks, effects, interactions. Yeah, 3 things. Okay, so now we're checking. We want to check that value is less than or equal to the balance. What's my balances? Sorry. Balances. Oh my god. Balances of the message sender. This is because we don't want anyone to be sending more than what they have, right? And we can specify an error string for when it's not followed. So in this case, let's say a good way to name it is, well, how I do it is first I open up with the name contract dot the function. So it's token dot transfer colon and the error, like not enough tokens, right? Okay, so that's what we want to check, that the balances of the owner is enough to cover what he wants to send. Before, you had to check something else like require what do you call that, just to check for overflows. That this isn't required anymore, but just so that you know, balances of the um, to address will be less than their balances when you add the value. This is because before you could overflow. So technically, this will most often be true because if you're transferring 10, 100, if the other account has 100 and you're transferring 10, their balance now, which is 100, will always be less than their balance when they're transferred that plus 10, right? But there are scenarios wherein you are at the very tip of the variable, the yeah, of the uint, in which case it could underflow. So from a very high value, you could go back to 0. But because of 0.8, you don't need this anymore. So let's take this out. And now we have the checks and we do the effects. The effect here is we want the balance of the user to be subtracted, right? So balances of the message sender, because in this case, the message sender will be the one calling the function, will be balances message sender minus the value, right? Another way of writing this is just, right, easier. If you want to be explicit, you can do this. I normally just do it like this. Easier to read. Next, we've decreased the value of the sender, but we also want to increase the balance of the receiver. So balance is 2 plus equals value. We know from here, transfer, that transfers must fire the transfer event. We do emit transfer. So where did it come from? It came from message.sender, and we're sending it to the to address, and the value is value. Now we're emitting transfer. And the last thing is we want to return true because the transaction has been a success. Okay. So when we compile this and we deploy, we should now have a function that can, we now have a contract that can transfer tokens. So instead of just earlier wherein we had total supply and all the getter values, we can see that I can now transfer. This is the second account. I'm going to check the balance. This is supposed to be 0. And what I can do now is using the account that has balance, I can transfer. Right? I want to transfer to that account. I want to transfer this 100. So And be careful, this 100 doesn't mean 100 tokens because you have decimals. If you want 100, actually, you'd need to add in 18 zeros after that. But for the sake of easier way to check, demonstrate, you can do it like this. Then transfer. Okay, if you check total supply, it's still going to be same because it's not gonna affect total supply. We didn't really mint anything. We didn't create more tokens. But if we check balance, you can see that the balance of the receiver increased by 100 and the balance of the sender should have decreased. Right? Earlier it was 1 billion times 10 to the 18. Now you have 100 missing, exactly as intended, right? But now let's test that the other contract should not be able to send more than what he has. So I'm gonna send it back. I'm gonna send back 110. And it should throw an error. And in this case, it did throw an error. The error specifically was token.transfer, not enough tokens, what we've put in the require function. Right? Okay. But if we do 100, this should be okay. And if you check the balances again, it's back to what it was before. Right? Now we have transfer. Any questions? Okay, not really seeing anything yet. Hopefully we can all follow. Next is we implement the other functions required. So we have here transfer from, approve, and allowance. So transfer from is a way to transfer from an address that isn't what you're using to another address. But to do so, you need to have allowance. And to have allowance, the owner of the from address needs to approve you. So let's not do transfer from yet. Instead, let's do allowance. So let's copy this. In the style guide, you can actually see some suggestions on how to format and group your transactions. Ideally, you group your views together, public views, then your internals, or depending on how your what's that called? Internal style works. It could be different as long as you're consistent. That's fine. So let's put this above transfer because I want to group my views together. Okay, so allowance, it means to return an approved amount. So again, this is similar to mapping. And we want to map, because it's an allowance, we want to map to an address, UN256 again. Let's make it internal. Allowances, right? And allowance will just return that value. Return allowances. Oops, actually, one more thing is it's mapped to, let's do this again. So an address will be mapped to a UN, but a mapping, you can put a mapping inside of a mapping. So mapping an address to a mapping of an address to a UN56. Internal, it is allowances. Okay. Normally I think I use private, not sure. Okay, either way, what this means is that when you give allowances an address and another address, it's gonna show you a UN256. This is because when we call allowance, you want to know who the owner is. So the owner is the owner of the tokens and who the specific spender is. So for allowances, you provide the owner and the spender. And this will give you the UN256 or how much they should be able to transfer on behalf of the owner. So it's like the owner on behalf of the spender will give you the allowance. So if you do this, it's just going to be 0 because we don't really have a function to modify allowances yet. So let's get to that. The function to modify allowances is approve. Let's copy paste here. Read this. Allows the spender to withdraw from your account multiple times up to the value amount. If this function is called again, it overrides the function, the current allowance with value. So it doesn't increase. It just, if you call approve, it won't increase the current value. It's just going to override the existing value. Yeah, and this should actually call approval. This should emit approval afterwards. So let's have that function. Function approve. Okay, so spender is all okay. So again, you want to specify the spender and how many. So as the owner, you are going to specify the spender and how much you want them to spend. It's public, it's not view, and it returns bool success, similar to transfer. So again here, actually for this, we don't really need to add in any requires because they can approve an amount that they don't necessarily have because the checking of transfer won't happen here. And for a lot of cases, that is actually the case. If you're dealing with a lot of bridges or just markets, DeFi or DEXs, traditionally they approve a arbitrarily big number so that when they transact, you don't need to approve again. It's just gonna reduce from the approval amount, which in this case is extraordinarily high. And it's basically just not, it's for you to not approve every time. But if you want to be more careful, you can approve the exact amount every time. It's just gonna have you spending more time and gas because you're approving transactions before they're happening. Okay. So how do we do this? So to do this, we just allowances, right? So allowances, we assign to allowances the owner. So for allowances, it's owner first, right? And the owner in this case is the message sender, because as the message sender, you are calling the approve function, and you are the message sender. You want to specify the spender. The spender is here, and you want to give the value. So this is basically how you edit the allowances. But as we've seen here, we want to emit the approval event. And the approval event is emit approval. And we want to have owner. In this case, it's the message sender, which is yourself. The spender, and the value. We want to emit that. Lastly, we want to return true because the transaction has been successful. Okay, so this is approved. So let's try to deploy this. Right? Command S to compile. Let's go to deploy. Okay. Right now we have another getter function. We have another view function, an allowance. For allowance, you specify who the owner is because you can check for other people. Right? Let's say that the owner is this account that deployed. So never mind. I will redeploy again. Transact. The owner is the deployer. Right? The primary account. Next, we have the secondary account, which should be the spender. And if we call this, the allowance is 0 because we did not set anything yet for them. So now let us set the value. So we call approve. For approve, we want to approve the spender. So we want to put the spender here, but make sure that the account you have chosen is the account you want is the owner account or the one that has the tokens, right? In this case, it's the first one because this account has all the balances, right? We want to allow him to spend up to 1,000 tokens. Again, disregard the decimals just for the sake of an easy demonstration. When we transact, it's gonna say, yay, successful. You can even see that the event is emitted here. So in Remix, these are your transactions. These are your calls. Calls are view functions, is the blue ones. So I'm gonna show you more details if you click on it. The green ones, they are your transactions. It's a check mark if it's successful, X if it was not, if it reverted. It's gonna put in the event also. Events come from the logs, and these are the topics. Right? Okay, so back then we can check allowance. Previously it was 0, but because we called approve, it should be 1,000. Right. So now we have several functions for our smart contract, for our ERC20 smart contract. Okay, there's a request here to run down the functions. It's fine. It's easy enough to do. So we have our variables, right? We have name, symbol, decimals, and total supply. What I did here is decimals, I made it public, so it creates a getter function automatically. So you can either do it internal, private. Well, I think normally it's private. I think it should be private. Then for the ones you made internal or private, you need to create a getter function. So for these, I made name, symbol, and total supply. I also made them for balances and allowances. Right. But for decimals, I have it here, even though I don't have any of those functions because it's already public and it automatically creates a getter function. For balances, we have a mapping because we want to assign a UN256, which is basically the number, to an address so that every address we can map a balance of up to UN256. For balances, for mappings actually, everything is initialized at 0 value. So for a mapping of a UN256, it initializes at 0. When you map an address, it initializes at address 0, which is 0x0x000, right? For allowances, it's more complicated. We're mapping an address to a uint because we want to assign the owner to a spender to an allowance, right? We also have some events, which are ways for outside applications to listen to what's happening to our smart contract. We have a constructor, which is how we initialize the smart contract. And we have these functions, the getter functions I mentioned. We have the functions of balance of and allowance to return the balance and allowance. We have transfer, which allows us to transfer our tokens, and approve, which allows us to approve the tokens that we have. Okay, so the last function that we need to implement is transfer from. Transfer from is when from another account we're moving balances on behalf of them. And to be able to do this, we need to have allowance to do that. Right? That's why we did approve first. Put this here. Later. Okay. Again, transfer from, you want to specify where it's coming from, who it's going to, and value, as opposed to transfer, which is you're transferring your own money, so you don't really need to specify where it's coming from. It's coming from you, so you just need to say to and value. Okay, it's public. It's not view because it's editing something, right? And it returns bool success. For transfer from, we want to check two things. We want to check, same as earlier, let's just copy paste. We want to check that the value you're transferring is greater than the balance of the owner. And in this case, the owner is not message sender because you are not the owner. the owner is from, and we want to specify token that transfer from, not enough tokens. That's fine. And the other thing that we want to check is that more than not just the balance of the owner, is that if the message sender has enough allowance to actually call transfer form function. So calling allowances. So for allowance, it's the owner first, right? So the owner is from, and the spender is message, not sender. Yeah, I think that's correct. Any comments from earlier? Okay, nothing yet. Yes, because if we don't check for this, anybody can just drain the account of anybody else. So that's why we need to check allowance. So token, not transfer from, insufficient allowance. Cool. Okay. Now we do the same as earlier. We edit balances. So it's again checks, effects, interaction. So now our effect is that balances, again, not of message sender, but from should be deducted by the value that you sent. The balances still of 2, because we're still the beneficiary, is increased by that same value, and we emit transfer. In this case, the transfer, it's not coming from message sender, again, right? It's coming from going to 2, and the amount is value. So again, transfer is from, to, and value. So earlier it was message sender because message sender is from, to is the same, value is value. In this case, it's coming from. And lastly, we need to return true. Okay, that's not lastly. There is something missing here. Balances, yes. So what's missing here is we modified the balances, but we did not modify the allowances. So this means if I allowed you to spend 1,000, and if I leave the function as this, you can send 1,000, and when you send 1,000, you can still call to send another 1,000 because we're not really decrementing your balance. So let's do that. Or your allowance. So allowance of the, you know what? I'm going to show you how that works first before we go through that. Without that, let's deploy this. I mean that address. Okay, right. So let's go straight approving. Spender. This 1,000 transact, right? Allowance now should be, oops. 1,000. If I have now transfer from, so when I use AB8, the account I've allowed, I can call from. In this case, the from is 5B3. I want to transfer to my own address. I want to transfer 1,000. If I call this, it's going to be successful. If I check my own balance, I'm going to have 1,000. I was allowed 1,000, but because I have a bug, I can transact again. And it was successful. Now my balance is 2,000 because I was not able to reduce allowances. So now let's do that. So allowances, first for allowances, we do owner. So the owner again is from, and the spender is message.sender. subtract value. This should act properly. Okay. Let's try again. Okay, where was I? Let's do approve. Oops. Copy the second account, approve the second account. 1,000. Let's check the allowance. Allowance of the spender and the owner should be 1,000, right? Before we try that, let's try the third account. Using the third account, it's expected that I shouldn't be able to call transfer from because I was not given any allowances. So the owner is from 5v3. 2 is, let's say, I want to transfer to the third account because I'm trying to drain the money. I'm trying to get 1,000. This is gonna be an X. The error is not enough tokens. You even have a misspelling. But if we call this using the second account, we just transact. Okay, something wrong. What's happening? Who did I? Okay. Where was I? From 5p8. Wait. Not enough tokens. Why is that the case? Oh, sorry. I have to repeat because my deployer earlier was not 5v8. It was the second account. Let's do that again. All right. So I should have balance, right? That's the case. Approving second account. Approving 1,000. The allowance is 1,000. Okay. Now when I call transfer from 5v3, transferring to myself because I want to get the money, but I am allowed to get the money, right? And if I do transact, oh my God, what the hell is happening? Oh, sorry. I'm using the first account still. I need to transfer to the second account. Transact, and it's successful. If I check the balances, first person was subtracted, second account is now 1,000. If I check allowance, it's 0, and if I try to call it again, it's going to be an error. So this is basically the whole smart contract for an ERC20 token. We've ended at exactly 7:30. Wow. Just for additional knowledge, if you go to Open Zeppelin, look at ERC20 GitHub. There are implementations here. You don't need to do it from scratch like we did because they have implementations to do it for you. So they're importing the interfaces. Oh yeah, they're using private. They have the constructors, the name, symbol, supply, transfers. But for here, they have an internal function to actually help out for the transfer because they're using it for both transfer and transfer from. This, I think, saves a bit on gas when it comes to deploying. It makes the code easier to read. You also have transactions to mint and even burn. So the best way to actually create smart contract would be to refer to Open Zeppelin, especially when that smart contract is following a specific standards because they have their own implementations for various standards like for tokens 721, 1155, 20, and even ERC 777. Right. So aside from that, they also have other implementations for governance, other helper functions, which you might be able to use even if you're not using a known standard. Um, it's good to reference OpenZeppelin. Again, if you want to learn more, you can look at the docs. Solidity has good documentation. They have learned by example. I think I've asked them to provide this as a bit of a pre-read. It might be long if you go through it, but it's very helpful. It's actually where I've learned Solidity. Yeah. You also have some. I think I asked them to provide a site that has a learning resource. I don't have it with me right now, but that's more on afterwards once you know Solidity. But I think they have it has Ethernauts, which is it opens up in some challenges because we know coding is best learned while you're doing things. You also go to Crypto Zombies. Although Crypto Zombies, I think is a bit outdated because they're using uh, older version of Solidity, but it's still a good way to learn. Just make sure to update your learnings every now and then. There's actually this one other site I used before, Capture the Ether. This is how you can get familiarized with smart contract security. I've played this before, actually in the leaderboard. Well, not with my nickname, different one. But yeah, it hasn't been updated in a long time, but it's still a good way to know how certain patterns can be attacked. So that you know what to avoid, because you might be tempted to use specific properties as ways to do randomness, as ways to control usage. But you'll know with blockchain, it might not be the best thing to do. Okay, yeah, that's it for Solidity 101. I'll be answering questions if you have any. And I'll answer a couple now here from Kenny, I think. Where can we expect blockchain to be used in the future? Um, Actually, we don't need to look too far into the future to actually see where blockchain is used because it's being used now. I mean, we have DeFi, decentralized finance, if you've heard about that, um, wherein you have the block cryptocurrency people basically just establish their own cryptocurrency markets outside of centralized finance. You have pools like Uniswap, SushiSwap, which are the centralized exchanges without middlemen, right? Technically, you can go through their site, but if you so choose, you can interact directly with their smart contracts. Right? You don't even need to go through their website if you're that paranoid. Um, Aside from current use cases, people are looking into using it for governance, voting. It's been a big research topic actually to solve the problem of voting, wherein the transparency while still maintaining privacy, just so that you can make sure that your vote has been counted and nothing bad's been happening. It's a possible research agenda for identity, identity cards. Logistics and ownership can be put on blockchain. Right now, NFTs are used for, what do you call that? JPEGs, right? But even before that was a big use case in 2020, people have already been looking at using NFTs for ownerships for land titles, for concert tickets, for music rights, royalty. That's one thing. For business, Um, Basically, it's a way to transform current processes. Blockchain is a transformative technology. Um, the way I say to people interested in going to blockchain, even programming blockchain, is that don't blockchainize an existing process. Look at what you want to achieve and create a process that blockchain enables. Because one of the common downfalls of a lot of use cases, they just take the current process and add blockchain to it, making it more complex and not really that streamlined. But you can, if you blockchainize a process, makes it might give you that competitive edge that traditional tech won't be able to give you. Okay, I'm gonna keep answering the questions. Just interrupt me if there's anything happening. How does a blockchain maintain security? Security happens through through the consensus mechanism. So depends on what blockchain you're talking about. Um, so for Bitcoin, it's proof of work. For Solidity, it's also for Solidity. Sorry, for Ethereum, it's also proof of work, but they are transitioning to proof of stake, with the merge supposedly coming this September. Right, other chains are using proof of stake as well, although some are using delegated proof of stake. Um, and other security measures are, well, for example, let's talk. That's about blockchain security, but you also have smart contract security, which is making sure that your inputs and interactions are correct. So to do that, you have to go through various audits and unit tests, because blockchain, a lot of hacks can happen, because for traditional tech, your code is obfuscated. You have that ability that your APIs, it's hidden on the back end. People don't really know what's happening on the back end. They just know that that it that something's happening, right? But they don't know the exact code, so they don't know. They can't see if anything's if there's an exploit they can do. But for smart contracts are on chain. A lot of times they're verified, so you can see the code somewhere so that people can interact with it and they know what they're interacting with. And that's actually how people prefer smart contracts be the code be publicly available. And that comes with issues that people can directly attack your code if you have a bug. So even though if you can't see a bug, people smart enough, persistent enough, might be able to see something. And it's not unheard of. It's been happening yearly, maybe even monthly, right? Something just happened with Nomad. A lot of bridges get hacked, right? So you have that. So really, audits, unit tests, and best security practice are top of mind whenever you're building on blockchain smart contracts. Is Solidity focused more on blockchain technology that other programming languages is not, or any similarity? Solidity is specifically used for smart contract language on EVM-based blockchains. We also have alternatives. I'm not sure how further they are in capabilities, but we have alternatives like Viper. So Solidity has similarities with um, JavaScript, maybe even TypeScript if you consider it statically typed, right? But when we're talking about how you declare functions, the function flow, it's very similar to JavaScript. Viper is similar to Python, hence Python Viper, right? Um, so really, Solidity is for smart contracts. When you want to interact with the blockchain, you still need to use something else. A lot of times it's going to be JavaScript when you're interacting with Solidity. There is a library we call Web3.js, Ethers.js, and I think, yeah, those two are the primary ones that you'll be using to be able to actually interact, because this is for the smart contracts. Smart contracts dictate what happens on the blockchain, but to actually connect your front end or your app to the blockchain, you have to do it through JavaScript or some other similar programming language, primarily JavaScript. Um, yeah. Okay. Similar to access token, does this refer to anything? I'm gonna assume this referred to the ones I was talking about earlier regarding NFTs and ownership tokens, right? Yes, it is. I think the idea of an access token is a bit similar to it, that you are providing a token that will provide access to a utility. This can be in the form of ERC721 if it's non fungible, or sometimes it could be an ERC20. Like you might require a specific amount of tokens in order to access a utility. So there are ways to do it, but tokens are a way to limit access. Yeah. Can Bitcoin be separated from blockchain? Bitcoin is on the blockchain. When you want to transact Bitcoin, you would think it happens on the Bitcoin blockchain, right? But of course, you have centralized exchanges that have um, order books, that have their own systems, so that when you buy and sell from them, you might not be interacting with the Bitcoin blockchain. You're interacting with their books, but the expectations is that when you want to take out your Bitcoin, it will be transferred to on the blockchain to your address. So we call that custodial accounts, wherein the Bitcoin technically is not on your address. It's still on the blockchain. So make no mistake, from what I'm saying, you can't really take out a Bitcoin from the blockchain, but um, you can technically trade it without really accessing the blockchain through centralized exchanges or custodial exchanges. Yeah, I think that's one of the last questions. If there's any I've missed.
Okay, so I think as much as we wanted to answer all of your questions, that's it for our Q&A session. So again, thank you so much, Marco, for giving that very enlightening and informative presentation. Knowing that many of our participants and viewers are various types of courses that involve technology and have expressed interest in the future trends of the IT industry, this was very insightful. And of course, before we dive into our announcements, is there anything else you wanted to add, Marco?
No, I'm good. Thank you for having me. I think so yun na lang. If you're interested, uh, just read up. There's a lot of um, information on the net. The documentation, especially for Ethereum, is really good. I mean, if I was able to do it online, I was self-taught online, so it's certainly possible. Um, my source of all places was actually Reddit and the documentation, but really a lot of the discussions on Reddit was helpful, and Ethereum Stack Exchange really helped. So just try it out, check out the sites I've shown earlier and the sites that they gave you as a pre-read. That's
Okay, so
it.
thank you so much again, Marco, for your presentation, and thank you to everyone for your questions, and thank you, Marco, for answering our participants' questions, and of course for that very insightful presentation. Okay, now for the announcements of upcoming events of Stack League. So, for Cebuanos out there, get ready to take on the Cebu Stack League Challenge. Join us on August 6th, Saturday, 1 p.m. at the company Cebu Mandaue branch for a free face-to-face event. And of course, Stack League WordPress Baguio user group, New Normal Schools, and WordPress on August 10, Wednesday at 6 p.m. And you may also join Genesis Blocks Breeder DAO Hackathon, a virtual blockchain hackathon in partnership with Stack League, with 200,000 cash prize pool on August 19 to 21. So deadline of registration is extended until August 12 of 2022. And of course, we have our Stack League Abacada Studios career session, ideating the digital classroom using gamification on August 24, Wednesday at 6 p.m. So there are plenty of opportunities for you to learn here in StackLeague. Just go to fb.com/StackLeague/events for the registration details and get the latest updates. And to help the StackLeague team improve the session for you, answer the question form. It's bit.ly/StackLeague session feedback, or you can scan the QR code flashed on your screen. So this was the same QR code flashed earlier, so you may scan the QR code so we can help us with your feedbacks. Okay, so StackLeague Ambassador for August is still accepting or now accepting entries. To earn your points or your ambassador points, you can either refer to friends and family or submit your blog sharing your StackLeague experience, or you can do both actually. So just visit bit.ly/StackLeague Ambassador 2022 for more information. Also, make sure to earn your league points to unlock the challenger levels and receive the prizes. And don't forget to also check out the StackLeague Lightning Series. Again, the schedule for the Lightning Series is always on the second Tuesday for unranked category, third Tuesday for bronze category, and fourth Tuesday for silver category. For more details, visit bit.ly/Lightning Series mechanics. And so that's all for our announcements. Okay, so on behalf of StackLeague team, I would like to say thank you to everybody for joining the StackLeague Tech Session Solidity with Marco Lorenzo Romero. This has been your host, King, and if you don't have a StackLeague account yet, make sure to sign up now at StackLeague.com, and of course, invite your friends and family who you think should be part of the league. So see you guys at the next StackLeague event. Again, this has been your host, King. Good night, everyone.